Exercise 1.1, question number 6. Show that the relation R in the set 1, 2, 3 given by this is symmetric but neither reflexive nor transitive. So here we have to first show for reflexive. It is not reflexive. Why? Because as 1 belongs to this set, I will consider this set as A. 1 belongs to A, but 1 comma 1 doesn't belong to R. So it is not reflexive. Now check for symmetric. Symmetric 1 comma 2 belongs to R and 2 comma 1 is also belongs to R. So it means it is symmetric. If 1 comma 2 belongs to R, implies 2 comma 1 belongs to R. If 2 comma 1 belongs to R, implies 1 comma 2 belongs to R. So for transitive, 1 comma 2 and 2 comma 1 belongs to R, but 1 comma 1 doesn't belong to R. This element should be common and then these two should belongs to R, then only it will be transitive. So here 1 comma 2, 2 comma 1 belongs to R, but this 1 comma 1 doesn't belong to R, so it is not transitive. So this relation R is neither reflexive nor transitive, but it is symmetric. Symmetric means if A comma B belongs to R, then B comma A should also belongs to R. So here it is true in this case, so it is symmetric. Now the next is show that the relation R in the set A. What is A here? A is a set of all the books in a library of a college given by R is equal to X comma Y. X and Y have the same number of pages is an equivalence relation. So here I have to show that it is an equivalence relation. So I have to show that it is reflexive, it is symmetric and it is transitive. So for reflexive, we know that X and X have same number of pages. Any two same books will have same number of pages. So it means for all X belongs to, or we can write for all like this, for all X belongs to A, X comma X definitely belongs to R. So it is reflexive. So we will write R is reflexive. Now for symmetric, X comma Y belongs to R. What does it mean? It means that X and Y have same number of pages. If X and Y have same number of pages, then obviously Y and X also will have same number of pages. We can just write them in reverse order. Then we can say that Y comma X belongs to R because Y and X have same number of pages. So X comma Y belongs to R implies Y comma X belongs to R. So it is symmetric. So we will write R is symmetric. Now for transitive. For transitive we will consider X comma Y and Y comma Z belongs to R. Now X comma Y and Y comma Z belongs to R. What does it mean? X and Y have same number of pages. Y and Z have same number of pages. These three are the books. X, Y and Z are the books. X and Y have same number of pages and Y and Z have same number of pages. Y and Z have same number of pages. Then obviously X and Z will also have same number of pages. So if X and Z have same number of pages, X and Z have same number of pages, then X comma Z belongs to R. So this implies X comma Z belongs to R. So if X comma Y, Y comma Z belongs to R implies X comma Z belongs to R. So it means it is transitive. We will write this implies it is transitive. Now next question is question number 8. Show that the relation R in the set A 1, 2, 3, 4, 5 given by R A comma B where mod of A minus B is even is an equivalence relation. So here also I have to show that it is an equivalence relation. So I have to show that it is reflexive, symmetric as well as transitive. So let us first show for reflexive. Now we know that what will be A minus A? 0, which is even. Always 0 will always be even. So we will write, or we can write 0 as odd also, but here we need even. So 0 which is even. So A minus A is even. A minus A is even. So it means A comma A belongs to R. So this implies A comma A belongs to R. So it is reflexive. Now for symmetric, we will write A minus B is even. Or why it is even? As we have taken A comma B belongs to R. Now I have to show that B comma A belongs to R. Now if A minus B is even, obviously B minus A will also be even. How? See, I have considered here 2 and 4. 2 minus 4 is minus 2 and mod of minus 2 is 2. So 2 is even. If I will interchange their position like 4 minus 2. 4 minus 2 is 2, which is also even. So we will have B comma A belongs to R. Now A comma B belongs to R implies B comma A also belongs to R. So it is symmetric. We will write the relation is symmetric. Now we will have the next transitive part. We will do it here, transitive. For transitive, I should have A comma B, B comma C belongs to R. What does it mean? It means A minus B is even and B minus C is also even. So if their mods are even, then the number will also be even. So A minus B is also even, B minus C is also even. And if I will add two even numbers, then also I will get even number only. If I will add two even numbers, I will get even number only, like 2 plus 4, 4 plus 10. We will always get even number. So minus B and plus B will get cancelled. So A minus C is even. If A minus C is even, mod of A minus C will also be even. So what does it mean? A comma C belongs to R. So A comma B, B comma C belongs to R implies A comma C belongs to R. So it means it is transitive. Now the next part of the question is show that all the elements of 1, 3, 5 are related to each other and all the elements of 2, 4 are related to each other. Now here this related means with respect to this relation R. So I have to show that 1, 3, 5, all the elements of this are related to each other with respect to this R. So we know that the difference of these numbers will always be even with each other. Like 1 minus 1, 3 minus 3 and 5 minus 5 will be 0, which is even. 1 minus 3 is 2, 1 minus 5 is 4. Because it is mod there, so we will consider it positive only. 1 minus 5 is minus 4, but we will consider it as 4. 3 minus 5 will be 2. Mod of 3 minus 5 is 2. So we will, if I will subtract these any of these elements with each other, I will always get a even number. Why? Because the difference of any two odd number will always be even. So what we are going to write here, for this we will write as difference of any two odd numbers is always even. So 1, 3, 5, all the elements here are related to each other. So all elements in 1, 3, 5 are related to each other. Same thing we will write for 2, 4 as well. In 2, 4, the difference of any two odd number will always be, the difference of any two even number also will always be even. So the same line we will write as difference of any two even number is always even. So all elements in 2, 4 are related to each other, as they have asked us for 2, 4 also. But they are saying show that no element of 1, 3, 5 is related to any element of 2, 4. So that is also obvious. These two sets, no element of this are related with this set. Why? Because the difference of these will not be even. 1 minus 2 is 1. 3 minus 4 is 1. 5 minus 2 is 3. 5 minus 4 is 1. So all odd. So difference of odd and even number will always be odd. So what we will write? Difference of one odd and one even number will always be odd. So elements of 1, 3, 5 will not be related to elements of 2, 4, because one set is having odd elements and one set is having even elements, and the difference between odd and even number will always be odd. So these two are not related to each other.